So let's see if we can't do this probability problem right here. So I'm going to draw a marble, one marble out of a bag. Well, it says, and then I'm going to draw another without replacing the first one. The probability of the second event is different from the probability of the first because they are dependent. But let's look at A first. So A says, what is the probability of drawing a red marble out of a bag containing 3 red and 7 blue marbles? So I have 3 red, 7 blue. My total sample space is 10 marbles. So P red is going to be, well, the number of favorable outcomes that are possible, 3, out of the total outcomes, which is 10. So my probability is going to be 0.30. That is P red. Now the second question, though, says, what is the probability of drawing a second red marble if a red marble is drawn the first time and not replaced? So here's the formula for this kind of a problem. It's a compound event, and they are dependent events. So I would write it P red and red again will be equal to P red times the probability of red again after I pulled out my first red. So this is going to be, well, we know, so P, we'll call it R and R, red and red, is equal to, well, we know our first probability is 3 out of 10 times, well, we better think about this a little bit before we jump to conclusions. This is what I had in my bag originally. 3 red, 7 blue, 10 marbles total. I removed one of the red marbles. Now, my probability of pulling a red is 2 red marbles out of 9 probable ones, not 10. So my total probability, my P, R, and R, would be 6 over 9, which I can simplify to 1 over 15, and in decimals, 1 divided by 15, 7 probability. So this raises a couple of things. So when you have a dependent event, it's not only that you're removing one from your sample space, you might also be removing one of your possible desired outcomes. So the lesson here is when you can, is draw a picture. And that will help you solve a